Hello everyone, welcome back to the channel. In this video, we are going to discuss a GATE 2025 linear algebra problem and its complete solution. After that, we will see the core concepts involved behind the above problem. And finally, we will solve a few practice problems plus some problems for you to try yourself. So, let's begin. So the problem statement is let A is equal to In plus x into x transpose, where In is the n cross n identity matrix and x is an n-dimensional vector such that x transpose s is equal to 1, which means the norm of x square is equal to 1. That is, the norm of x is equal to 1 from this. We need to find which of the following options is or are correct. Rank of A is n, A is invertible, 0 is an eigenvalue of A inverse has negative eigenvalue. So moving on to the solution. Before going into the solution, first we will see what does this x into x transpose means. Okay, since we have given A is equal to In plus x into x transpose, first we will see how does this x into x transpose indicate. So let's take V be any vector. Then if we see how this V acts on XX transpose, then if we multiply this XX transpose with V, then this and this term we can write as x into x transpose V, x into x transpose V. Since this x transpose V is an inner product of x with V, and we know that inner product is always a scalar quantity. If we take this term as C, then we get this C into x. Okay, what do we get is xx transpose V is equal to C into x, which means if we take any vector V and multiply it with xx transpose, then we get another vector in the direction of x only. What does that mean is, that means if we take any vector V and we take xx transpose, that xx transpose can generate a vector in the direction of x only. So which means is xx transpose V always gives a multiple of x. Okay, always x transpose V always gives a multiple of x. First thing. Second thing is xx transpose cannot generate any new direction beside x. Okay, xx transpose only generate a vector in the direction of x only. Whatever v takes, whatever we take, always xx transpose generate a vector in the direction of x only. That is, xx transpose can generate a vector in the direction of x only, and in only one direction, which is in x direction. Okay, so xx transpose can only generate cannot generate any new direction beside x. It can generate a vector in the direction of x only. That is why xx transpose has rank 1. Okay, this is one way of seeing how x into x transpose has rank 1. Another way we can see that if we look at xx transpose, then all the columns of x into x transpose are linearly dependent columns. Okay, and hence xx transpose has rank 1. Now, okay, now we have seen that any vector V when acts on x and xx transpose produce a vector in the direction of x only. So we can also think of xx transpose as a projection operator that projects any vector V onto direction of x, which means we can see this term xx transpose as a projection operator that will project any vector V into the direction of x only. Okay, so what does that mean is, if we have some component in x direction, and what if we don't have component in x direction, then what will happen, we'll see. That is, if we have some component in the direction of x along x direction, then that component remains. Okay, if v has no component along x direction, which means v is perpendicular to x, then if v is perpendicular to x, then we know that x inner product vanishes. That is, x transpose v is equal to 0. And if we see xx transpose into v, this can be written as x into x transpose v. But since v and x are perpendicular to each other, therefore x transpose v is equal to 0, and hence this term vanishes. What does that mean is, if v has no component along x direction, then the inner product of if v has no component along x direction, then xx transpose into v, this term vanishes. Okay, if we have some component along x direction, then that component remains. Okay, Now there is a note: whenever you see outer product like x into x transpose, and we have to do some analysis, like we have to find the eigenvalues, we need to find whether the given matrix is invertible, we need to find the determinant, we need to find the eigenvectors of the matrix. These sort of analysis if we have to do, then always the first step is to check how it acts on how xx transpose acts on two things. First, in the direction of x, that is x itself. So first thing we will check how x into xx transpose acts on the vector x, which means first we will see how this xx transpose acts on the vector x. Okay, now after that we will see how xx transpose acts on any vector which is perpendicular to x, which means xx transpose into y, here y is perpendicular to x. Okay, these two analysis we have to do. Now moving on to the solution of the question, which is we have given matrix A which is in plus x into x transpose, so that x is an n-dimensional vector and x transpose s is equal to 1. Now since we have x into x transpose in the problem statement, again the problem, so first thing we will check is how xx transpose acts on the vector x, and secondly how it acts on y which is perpendicular to x. These two things we have to check. Okay, first let's check how it acts on x. So we have a is equal to this, then a into x. First we will check how this act on x is a into x, which is equal to this term into x. Okay, then if we take this inside, then I into x plus xx transpose into x. I into x is nothing but just x, plus if we take this as outside, then this into x transpose x. But we know that in the question given x transpose x is equal to 1. Okay, if we put this x 1, and then we get ax is equal to x plus x. Okay, ax is equal to x plus x, that is ax is equal to 2x. Okay, this equation we got. Okay, so if we see this equation carefully, this equation is in form of ax is equal to lambda x, means this equation is in eigenvalue equation form. Okay, is in eigenvalue equation, which means x is an eigenvector of A corresponding to eigenvalue 2, which means hence we got one of the eigenvalue of matrix A is 2, corresponding to eigenvector lambda. Okay, now this what we have done is we have checked how xx transpose x on x in the direction, how it acts in the direction of x. Now we will check how it acts in the direction of y, which is perpendicular to x. So if we see ay, which is equal to this term into y, if we take this as inside, then this will become y plus x into x transpose y. But this term is 0, as we know, because y and x are orthogonal, y and x are perpendicular to each other. Okay, this term vanishes, and this is ay is equal to y. Okay, we can write that ay is equal to 1 into y. If we compare this from the eigenvalue equation, ax is equal to lambda x, we can get y is an eigenvector of A corresponding to eigenvalue lambda is equal to 1. Okay, and hence we get the second eigenvalue is 1. Okay, and the eigenvector corresponding this is y. Now if we see that this eigenvalue 1 has a multiplicity of n minus 1, which means A has one eigenvalue is equal to 2, another eigenvalue is equal to 1 with multiplicity of n minus 1, and this is why we will see. Okay, let's say we are in 3 dimension. Okay, let's say we are in 3 dimension, and if we take a vector along x direction, and then there are two linearly independent directions, which are y and z. In that case, there are two linearly independent directions which is perpendicular to the given vector. Okay, which means in 3 dimension there are two linearly independent direction orthogonal to x. Okay, if we take a vector in x direction, then there are two linearly independent directions which is perpendicular to x. Okay, since in 3D there are two linearly independent direction which is perpendicular to x. Okay, whatever, hence if we see in n dimension, so there are n minus 1 linearly independent directions which is orthogonal to x, which means the eigenvalue lambda equal to 1 has a multiplicity of n minus 1. Why? Because there are n minus 1 directions in which we can take y, because there are n minus 1 directions which are orthogonal to x. Okay, since we can take this y into n minus 1 direction, and each time we'll get since each time y is orthogonal to x only, and hence each time we'll get ay is equal to y n minus 1 times. So we can say that this eigenvalue has multiplicity of n minus 1. Okay, so what we'll get is we'll get the eigenvalues of a are one eigenvalue is 2, another is 1 with a multiplicity of n minus 1. Okay, now we'll move into the solution. Exactly, first option is rank of a is n. Okay, since we know the eigenvalues of a are, well, lambda 1 is equal to 2 and lambda 2 is equal to 1 with a multiplicity of n minus 1. So if we see the determinant of a is not equal to 0, because none of the eigenvalue is 0, and hence we know if the determinant is not equal to 0, then the given matrix is full rank matrix. That is, the dimension of a is n, therefore the rank of a is n. Okay, secondly, a is invertible. Since we know that the determinant of a is not equal to 0 because it has no 0 eigenvalue. Okay, so yes, because all eigenvalues are non-zero, or determinant of a is not equal to 0. That is, 0 is an eigenvalue of a. This is wrong, because we know one eigenvalue is 2 and second another eigenvalue is 1 with a multiplicity of n minus 1. Okay, and the fourth option is a inverse has negative eigenvalue. This is also wrong, because we know that the eigenvalues of a inverse are 1 into eigenvalues of a, which is nothing but 1 by 2 and 1 by 1 with a multiplicity of n minus 1, and hence this is also wrong. Now we'll see the core concepts behind the above problem. So the first one is x transpose into v always gives a multiple of x. Why? Because we have seen x transpose v is equal to c of x. Whatever v you take, always this product will be in the direction of x only. Or we can say that x transpose cannot generate any direction beside x. That is, x transpose can generate a vector only in the direction of x. Okay, this is the reason why x transpose has rank 1, because it can generate a vector only in the direction of x. That is, it can generate a vector only in single direction. And as we can say, the rank of x transpose is equal to 1, and provided that x is a non-zero vector. Okay, now second one is, we can also think of x transpose as a projection operator that projects any vector v onto the direction of x, which means x transpose v is equal to cx. Okay, this x transpose into v is equal to cx. This x transpose we can see, as a projection operator that projects v onto the direction of x. Okay, so in a problem, if you are seeing outer product like x transpose, or you whenever you see outer product like x into x transpose, or if you see u into v transpose, okay, this is also outer product. And then what you need to do is you need to first step to check how it acts on first in the direction of x, that is in the direction of x itself. What you will check is how this outer product behaves in the direction of x. Okay, this is first one. Second, you will check how this behaves in a direction perpendicular to x. That is, if we take y which is perpendicular to x, then how this xx transpose behaves in the direction of y. Okay, and using this, you can find out the eigenvalues or the eigenvectors of the given matrix, and then you can perform analysis. And you can, using this, you can easily find out eigenvalues of given a and then perform your analysis. Okay, now moving on to some practice problems. Okay, so first one is, suppose a is equal to u into v transpose. This is the outer product of u and v. Okay, is a column times a row, and u and v both are n dimensional vectors, such that u is not equal to 0, v is not equal to 0. Now we need to find out, first we need to find out eigenvalues of a. Second, we need to find out the determinant of a. And third, we need to find out whether a is invertible or not. And fourth, we need to find out trace of a. So I'll give you a hint. Since this is an outer product of u and v, so we need to check two conditions. First one is how this a behaves in the direction of u. Second is how this a behaves in the direction which is perpendicular to u. If you can perform these two analysis, then you can easily solve all the then you can easily do the analysis of the problem. Okay, and hence and then these four are the answers which are given. You can try it out. And the second problem is given b is equal to in plus u into v transpose. Again you see u and v both are n dimensional vectors, so the u is not equal to 0 and v is not equal to 0. What we need to do is, for what value of v transpose u, matrix b is not invertible. Okay, we need to find the value of v transpose u so that b is not invertible. Okay, since we have seen here also, this term is the outer product of u and v. Then what we need to do is we need to check how this behaves in the direction of u, and second is how this behaves in the direction perpendicular to u, and then we can able to solve this problem also. And the solution of this problem is c is equal to -1. Okay. If you have any doubts or queries, let me know in the comment section below. You can also join our Telegram channel for the discussion or to ask any doubts directly. And for more such content, don't forget to subscribe. Thank you.